In this video, we will do two main things. Firstly, we will introduce an alternative tool for scanning, which works especially well with reaver in terms of getting information about WPS usage in surrounding access points. Secondly, we will review the various kinds of challenges that one may face when trying to use reaver. This other tool that I mentioned is known as wash, and it is specifically designed to provide information about WPS usage in the various access points that can be detected around. AeroDumpNG that we have been using before is a more general purpose scanning tool and doesn't say as much about WPS. Since different information is provided by wash and AeroDumpNG, generally we may want to use both. Let's take a look at what we have. WLAN 0 in managed mode. If we try to do wash -i WLAN 0 when it's in managed mode, we get an error. So unlike AeroDumpNG, wash will not automatically put the wireless interface into monitor mode. But no big deal. So let's say we look at AeroDumpNG first. It will then put WLAN 0 into monitor mode. After that, then we can take a look at what wash will do for us. So anyway, we wanted to compare AeroDumpNG with wash. So we go ahead with AeroDumpNG, WLAN 0. So even though it's in managed mode, as we have done so many times before, AeroDumpNG will just automatically, for our convenience, set WLAN 0 into monitor mode. And it does that. So we are trying to see what's the difference as far as WPS is concerned in the information that is presented by AeroDumpNG versus the information presented by a tool like wash, which is specifically designed for scanning for WPS. One thing we note here is that we see things like WPA2, WPA, if there is WPA also show, but all these are WPA2, and a couple of WEP. Now, we don't see WPS mentioned here, so we cannot really tell from here if WPS is turned on. We can try with reaver, and then we'll get to know pretty soon. We'll get some error messages and we'll know that WPS is not enabled for a particular access point. But another way to know with more certainty is to use wash. So now that WLAN 0 is in monitor mode, now wash should be able to work. And we see that it gives a different output. So it doesn't put WPA2 CCMP, for example, but then it looks to see if WPS is enabled for these different access points. It scans on different channels and then shows the output. So this is one way we can know which access points have WPS, and then we can go try reaver on these access points. We encountered various challenges using reaver in the previous two videos. So here we would like to summarize some of these and talk a bit about things that can be done to help ourselves. One of the main problems using reaver these days is that modern access points include various countermeasures. One helpful point about reaver is that it saves the work previously done. It gives you the option to resume where you left off the next time, so you don't have to start again from the beginning. Besides the AP countermeasures, there are other problems using reaver that are more easily handled. One is signal related issues. So we saw things like association failures that happen quite frequently, and there's a couple of ways that we talked about to handle this. One was using better antennas with more antenna gain, and the other was trying to do the WPS attack when the network traffic was light. Here's a picture showing the same TP-Link wireless card and the antenna that it comes with, as well as another antenna which which has higher gain. Both of these are omnidirectional antennas, so it's not directional antennas, but this antenna with much higher gain is able to give something like 8 to 10 dB improvement of the signal strength compared with the antenna that it came with. It was easy to just unscrew this and then screw on this one. We will show a short video clip of how using reaver after hours improved the performance. I'm continuing this reaver attempting to get the WPS pin at a time when there's less traffic, so there's less load on the AP, and we see that it's much smoother. We don't have those failed associations. So we see that all these factors matter. Sometimes we see WPS transaction fail, and we can do a minus no next. That's a suggested way of dealing with it. We're seeing a 4x speed up in the 16 seconds of video. Yeah, so we didn't get that same error because we set the minus no next. Last but not least, the reaver software has some issues. So in the version that we were using that came with Kali Linux, I think that 2017, one of the 2017 builds of Kali Linux, there were problems in specifying the parameters. It's interesting that even this very important -k parameter, which is to use for including pixie dust, has a problem. Reaver comes with some help, so you should type reaver, maybe reaver -h or -help, just standard way of getting the help information. It gives an example on how to use reaver, but this example uses the -k flag in this way, -k space 1. If you try using that, you're going to get this weird error from reaver which says that the WPS pin is not found. And eventually you'll figure out that it should be -k equals 1, which you can kind of guess from the help as well. So here's a video clip showing what happens when you use -k space 1 as following the example from the reaver help. Unfortunately, reaver is going to be unable to find a pin and it's going to give up. The reason is because of the way that we specified the -k option.